What if everything you thought you knew about progress, reality, and even humanity's place in the universe was just the beginning?
Hmm.
Today, we're embarking on a deep dive into a truly bold vision, one of unlimited knowledge growth.
Yeah, that's quite something.
Our mission is to unpack some fascinating excerpts from David Deutsch's The Beginning of Infinity, a book that, well, it really challenges our fundamental assumptions about knowledge, about the cosmos.
It definitely does.
We're going to try and extract the most important nuggets of insight, helping you understand what it truly means for knowledge to be unbounded, how we create it, and, what your role might be in a universe that's, frankly, far stranger than you might ever have imagined.
And these aren't just like abstract philosophical concepts floating out there. The passages we've picked out, they lay out some really profound ideas on everything from, say, how scientific discovery actually works
Right.
to the objective reality of beauty, which is a fascinating one, and even the very structure of the physical world itself.
Okay, yeah.
So get ready for some potential aha moments as we sort of connect these ideas together.
Definitely sounds like it. Okay, let's unpack this maybe by first radically reconsidering our place in the cosmos. You know the image we all have, the serene night sky, the Milky Way, with its hundreds of billions of stars, this huge object we see from the inside. It feels so tranquil, doesn't it?
Yeah.
So vast and peaceful.
It does look that way. But that calm appearance hides a universe absolutely seething with violent activity. I mean, take a typical star, for instance.
Okay.
It's converting millions of tons of mass into energy every single second.
Millions of tons a second. Wow.
Yeah, and just to put that in perspective, each gram of material releases as much energy as an atom bomb per gram.
Staggering.
And it gets even more intense. The source material highlights that within the range of our best telescopes, right now there are literally several supernova explosions happening per second.
Per second, not per year, per second.
Per second. Each one briefly brighter than all the other stars in its entire galaxy combined. It's just an unimaginable burst of power.
Okay, that's hard to even picture.
It really is. And while we don't know, obviously, how many of these are horrendous tragedies for any potential life out there,
Right. We can only speculate.
we do know a supernova utterly devastates orbiting planets, just wipes out life. Its neutrino radiation alone could kill a human billions of kilometers away, even through, like, lead shielding.
Just the neutrinos.
Yes, sir.
Not even the blast wave or heat.
Just the neutrinos, lethal.
Yet here's the truly mind-bending paradox, isn't it? We owe our very existence to these colossal, destructive explosions.
Exactly. Supernovae are the source, through this process called cosmic transmutation, of most of the heavy elements that make up our bodies, our planet, everything around us.
So the atoms in my hand right now, the air you're breathing,
Yeah.
they were forged in that kind of unimaginable cosmic violence.
That's right. Our existence isn't some, peaceful miracle in a calm universe. It's a testament to the universe's explosive power, really.
Which kind of leads us to Earth itself, doesn't it?
Yeah.
We often hear our planet described as just a typical place in the universe, kind of average.
Yeah, that principle of mediocrity idea. But imagine traveling, say, millions of light years away into deep intergalactic space. What would you actually find there?
Not much. Cold, dark.
Oh, cold, dark, empty, vast emptiness with no scum. That's Deutsch's word for life. That is what's truly typical in the universe.
So this insight really challenges those common metaphors like spaceship Earth or that principle of mediocrity. I mean, those ideas were useful, right? They corrected the old sort of arrogant view that Earth was the center of everything, vast and permanent.
They did serve that purpose, yeah, countering parochialism. But their interpretations can be quite misleading if you take them too literally.
Because the counterintuitive truth, as Deutsch points out, is that primeval Earth, even places we kind of romanticize like the Great Rift Valley, they were absolute death traps for unprotected humans.
Absolutely. You wouldn't last long at all. The actual life support system we have now in places like Oxford or London or New York isn't natural. It's entirely human-built.
You mean like clothes, houses?
Clothes, houses, farms, hospitals, electrical grids, sewage systems, all of it. It's infrastructure. This highlights a crucial point from Richard Dawkins, who Deutsch cites.
Okay.
That human senses and brains evolved to cope with phenomena relevant to survival here on Earth. Mid-scale phenomena, not cosmic scales.
Right. So if our senses aren't designed for it, how on earth do we grasp concepts like, neutrinos or quasars or the Big Bang, things so far outside our direct experience.
That's the million-dollar question, isn't it? How do we, with our limited biological toolkit, grasp things that are so far beyond our immediate survival needs?
And perhaps the answer lies in how we build knowledge itself, how
Yeah.
we explain things.
Precisely. And that's where Deutsch introduces what he calls the engine of knowledge,
Mhm.
this relentless quest for good explanations. Think about it. For millennia, people dreamed of flying. They saw birds, they imagined it, but they only ever experienced falling, right?
Yeah, gravity always wins.
Until they discovered good explanatory theories about aerodynamics, about lift, about propulsion, and then, and only then, did they actually fly.
So science doesn't just observe and predict things that are already there. It actually brings about phenomena that are spectacularly different from anything seen before.
Exactly. Think about nuclear fission before 1945. That wasn't something people just stumbled upon.
No, it came from theory.
Or predicting planetary orbits accurately enough to send probes long before we could actually travel there. These things came from the explanation first.
Which brings us to a really fundamental concept Deutsch emphasizes: fallibilism.
Ah, yes, fallibilism. He argues that many misconceptions about knowledge, sort of our whole approach to it sometimes, stem from what he calls justificationism.
Justificationism, meaning
Meaning the quest for certainty or for social endorsement, for proving an idea is definitely true or has authority behind it, rather than just seeking the truth itself wherever it leads.
okay, so trying to prove you're right rather than trying to find out what is right.
Kind of, yeah. And the liberating concept here is fallibilism. Recognizing that there are no authoritative sources of knowledge, none, nor any reliable means of justifying ideas as definitively true or even probable.
Okay, now that might sound a bit bleak. Like we can never really know anything for sure.
It can sound that way initially, yeah.
Yeah.
But for Deutsch, it's the complete opposite of despair. It's the very means by which knowledge is created.
How so?
Because fallibilists expect even their best, most cherished explanations to contain misconceptions, to be imperfect. So they're always predisposed to look for flaws, to find ways to improve the theories.
So it's not about being right in some final sense, but about being radically open to being more right tomorrow. Always improving.
Exactly. And this mindset, this acceptance of fallibility, he states, is essential for the initiation of unlimited knowledge growth, the beginning of infinity. It's what kicks the whole process off.
Okay, so if we need good explanations, how do we define good? What makes an explanation good rather than bad?
Well, let's look at early human failure, as Deutsch puts it. For thousands upon thousands of generations, our ancestors, who had brains anatomically just like ours.
Same hardware.
Same hardware. They discovered literally nothing fundamental about the stars. They saw the lights, they told stories, but they failed to find what was really there behind those appearances.
So what changed? What was the breakthrough?
The scientific revolution brought this crucial methodological rule. A scientific theory must be testable, empirically testable.
Meaning it has to make predictions that could be contradicted by observation, right? If it's wrong, there must be some way to show it's wrong.
Spot on. He gives the example of Rutherford and Soddy, back in the day, refuting the old alchemical idea of impossible transmutation by actually demonstrating radium being created from uranium.
They showed it could happen, testing the impossible claim.
Exactly. They tested it, and the old idea was refuted. Now, contrast that with an ancient theory, like, say, everything's made of earth, air, fire, and water. How do you even test that?
You can't really disprove it with an experiment, can you? It's too vague.
Precisely. It's untestable, so it could never be improved through experiment or observation.
But Deutsch says it's more than just being testable, right?
Yes, much more. It's not just about rejecting authority or demanding tests. It's fundamentally about seeking better explanations. Explanations that are, well, good.
And what makes an explanation bad, then, even if it is technically testable?
He points out that bad explanations, these are theories that are easily variable. Think myths, superstitions, maybe a gambler's lucky charm theories.
Things you can easily tweak to fit the facts after they happen.
Exactly. They're almost useless for correcting errors because you can always adjust them. They allow people, as he says, to continue fooling themselves.
That reminds me of Richard Feynman's famous line, "Science is what we have learned about how to keep from fooling ourselves."
That's a perfect summary. It captures it beautifully.
So this quest for good explanations is, in Deutsch's view, the basic regulating principle, not just of science, but of the whole Enlightenment project.
That's his argument. And it implies rejecting authority, fostering a tradition of criticism, actively looking for flaws, and establishing a clear criterion for reality. A thing is real if, and only if, it figures in our best explanation of something.
Okay, can you give an example of a good versus a bad explanation in this sense?
Sure. Take the true explanation of the seasons. The Earth's axis is tilted relative to its orbit around the sun.
Right, basic astronomy.
This explanation is hard to vary. All its details, the specific tilt angle, the orbital path, the sun's radiation play functional roles. They connect to other known physics. They make specific predictions about temperature differences, day length changes, all independently testable. You can't just swap out the sun for, say, a giant cosmic fireplace. The details matter and are constrained by other knowledge.
Okay, it hangs together.
Now, contrast that with the ancient Greek myth of Persephone being abducted to the underworld, causing her mother Demeter's grief, which then causes winter.
The story.
Right. As an explanation for seasons, it's easy to vary. You could change who abducts her, why Demeter is sad, how long winter lasts. You can tweak the story endlessly, and it still works as a narrative. But it doesn't actually explain the underlying reality of why it gets colder or why days get shorter. It provides no actual knowledge about the mechanism.
It doesn't connect to other physics or make testable predictions about, say, the southern hemisphere having opposite seasons.
Exactly. It lacks that hardness, that resistance to arbitrary change, which is the hallmark of a good explanation.
So thinking about this, how might this fundamental difference challenge your assumptions, listener, about what you consider true in your own life? How could it reshape how you evaluate information, distinguishing explanations that are hard to vary from those that are, well, a bit too flexible?
That's a great question to ponder. And from the tangible universe and the nature of explanation, let's explore something even more mind-bending, perhaps. The multiverse and the surprising reality of abstractions.
Okay, multiverse. This always gets wild. But first, you mentioned instruments bringing us closer to reality, even while physically separating us.
Yeah, it seems counterintuitive, doesn't it? But think about Jocelyn Bell back in the 60s, seeing the first pulsar. She wasn't looking through a telescope eyepiece.
No, it was data, right? Wobbly lines on chart paper from a radio telescope.
Exactly, a shaky line of ink on paper. The instrument physically separated her from the star, but the information, interpreted through theory, brought her closer to the reality of that bizarre object than anyone had ever been. The instrument was a bridge, not a barrier.
Because all observation is theory-laden, as Deutsch puts it.
Precisely. Any error we make isn't just like our eyes playing tricks on us. It's fundamentally an error in our explanation of what you're observing. Our instruments and the theories built into them can correct for the deceptiveness of raw appearances. That's how knowledge grows, by correcting misconceptions embedded in our theories.
Okay, so that sets the stage. Now, the multiverse. Where does that fit in?
Right. Here's where it gets really interesting, as you said. Deutsch posits that the physical world we inhabit isn't just one universe, it's a multiverse.
Many worlds.
Many worlds, yes. What we experience as our universe or our history is actually just one emergent feature, one thread within this vastly larger multiverse.
So our reality is just one possibility playing out among countless others happening in parallel. That really does twist the brain.
It absolutely does. And this leads to a truly weird property of quantum physics called fungibility.
Fungibility. Like interchangeable thing.
Sort of, but with a quantum twist. Imagine a quantum realm where you can have absolutely identical copies of something, say 2 photons, but they can still be distinct in their ownership or their history within the multiverse. It's like Deutsch uses the analogy of dollars in a bank account.
Okay.
You might have $100, all identical, but maybe one specific dollar in that fungible set is earmarked for the tax authority. It's identical, yet somehow distinct in its abstract property or destination. Our everyday language really struggles to capture this diversity within fungibility.
So things can be identical but different simultaneously in some sense.
In the context of the multiverse, yes. And this relates to randomness. What appears to us as randomness in quantum events, like whether a radioactive atom decays now or later, isn't truly random in the multiverse view.
It's not. But quantum mechanics is famously probabilistic.
Well, according to this view, the underlying laws are deterministic, but they operate across the entire multiverse. The apparent randomness we see in our single universe is just a consequence of our limited perspective, reflecting the measure or proportion of universes where one outcome happens versus another.
So the coin flip always lands, both heads and tails, just in different branches of the multiverse, and we only see one.
That's the essence of it, yeah.
Yeah.
It totally reframes our understanding of chance.
And quantum interference fits into this too.
It does. Interference effects where, say, a single particle seems to go through two slits at once and interfere with itself demonstrate this interconnectedness. Instances of a particle in different histories or universes can subtly lose their individual identity and affect each other, even though they aren't communicating in the normal sense.
It's like ripples from different universes overlapping.
A bit like that, yeah.
Yeah.
It shows how these parallel histories are intimately linked and part of one larger structure.
Okay, wow. Let's shift gears slightly, but stay with the weirdness. Abstractions. You said they're more real than we think.
Definitely. Think about it. When a chess AI beats you, what actually beat you? Is it the physical silicon atoms in the computer's processor?
Well, no. It's the program, the strategy, the logic.
Exactly. It's the abstract program, the knowledge encoded within it. The physical hardware is just the medium.
Okay, I get that.
Douglas Hofstadter's 641 argument illustrates this perfectly. He imagines a complex domino computer simulation designed to factor numbers. If a specific domino representing a large number, say 641, doesn't fall when it should according to a simpler pattern, why?
Because the number is prime.
Exactly. Because 641 is prime, that's the explanation. And primeness, Deutsch argues, is a pure abstraction. It's a property of the number itself, a mathematical truth that transcends the physical arrangement of dominoes or silicon atoms.
It's the abstract property that causes the physical outcome.
That's the claim. The implication is profound. Abstractions, laws of physics, mathematical truths, the logic of computation, maybe even things like economic principles or rules of grammar exist objectively. Their truth value isn't just a convenient way we describe physical stuff.
So they're part of reality itself.
Yes. This really pushes the boundaries of what we traditionally consider physics versus mathematics or information theory. If a mathematical concept or a program's logic is what truly drives an outcome, how might your understanding of these things reflect a deeper reality than just the physical processes carrying them out?
That's a lot to think about, the reality of pure ideas.
It is. And this expansive understanding of knowledge, reality, and abstraction naturally extends to how ideas themselves evolve, which brings us to memes, culture, and humanity's unique place.
Right, memes. And you mentioned earlier, we're not just talking funny internet pictures here.
No, definitely not. Deutsch uses meme in Richard Dawkins's original, broader sense. Basically, any unit of cultural information, an idea, a skill, a belief, a fashion, a tune, a scientific theory that replicates and evolves by being passed between minds.
So cultures consist of these abstract replicators, these memes, analogous to genes in biology.
Analogous, yes, but with profound differences. Crucially, meme replication in humans isn't typically through simple imitation, like, say, how apes might learn specific behavior patterns by copying.
How does it work then?
It often occurs through creativity, through understanding the purpose behind an action or idea, and implicitly grasping the underlying rules. Think about language grammar.
Okay.
You use complex grammatical rules perfectly accurately all the time, even if you couldn't explicitly state what those rules are. You understood the purpose of communication and inferred the rules creatively. You weren't just mimicking sounds.
So it's understanding and recreating, not just copying.
Exactly. Which leads us to humanity's unique trajectory. Humans, Deutsch argues, are universal constructor.
Universal constructors, meaning?
Unlike almost all other organisms, which are highly adapted to specific environments, humans actively transform inhospitable environments into life support systems. We don't just find a niche, we create it. Our bodies and brains, he says, are effectively factories for transforming anything into anything that the laws of nature allow.
From raw materials to, well, iPhones and spaceships.
As much. And what makes this ability unique, the key difference, is that humans use explanatory knowledge, deep understanding, not just rules of thumb learned by rote or instinct.
And we create this explanatory knowledge through
Conjecture and criticism. Trial and error, but guided by reason and explanation. Not the blind process of genetic variation and natural selection that drives biological evolution. It's an active, intentional, creative process.
This implies there's a critical difference, then, between different kinds of memes.
Yes, a crucial distinction between what Deutsch calls rational and anti-rational memes. Rational memes replicate because they actually help their holders, they solve problems, they provide real benefits like a good scientific theory or a useful farming technique.
Okay, they work.
But anti-rational memes survive differently. They often replicate by disabling the critical faculties of their hosts. They make people resistant to questioning, skeptical of new ideas, or blindly obedient to tradition or authority. Think dogma, superstition, harmful ideologies.
They protect themselves by shutting down the questioning process.
Precisely. And Deutsch suggests that Western civilization historically is kind of an unstable transitional period, caught between the static anti-rational societies of the past and potentially dynamic, rational ones of the future.
And what about those static societies, the ones dominated by anti-rational memes?
Well, the bleak reality, he argues, is that they tend to survive only by extinguishing their members' creativity and breaking their spirits, enforcing conformity, or else they quickly disintegrate into chaos and violence when faced with change or crisis. It's a stark picture.
He gives the Easter Island example, doesn't he?
Yes, the prevailing theory at least. That the Rapa Nui culture became incredibly proficient at one thing, carving and moving giant statues, and prioritized this pattern of behavior above all else, even as deforestation led to ecological collapse and starvation.
So they demonstrated a fatal proficiency at sustaining a fixed cultural pattern, an anti-rational meme complex in this view, even when it led to their own ruin.
That's the interpretation, yes. Brilliant at one thing, but unable to adapt or criticize the core cultural project even when facing disaster.
And there's another example about resources, europium.
Ah, yes, the europium example. Fascinating. In the early days of color television, europium was a key element needed for the red phosphor. Experts at the time assessed known geological reserves and concluded it was extremely scarce, potentially limiting the entire technology.
So relying on existing knowledge painted a picture of limits.
Exactly. But that expert assessment completely missed the possibility of new knowledge. People then discovered vast new sources of europium and developed entirely new, more efficient methods for creating the red color. The limit wasn't real, it was just a limit of current knowledge.
So new knowledge didn't just solve the problem within the old constraints, it completely changed the definition of what was possible.
Precisely, which highlights Deutsch's concept of deep truths and reach. Ideas with reach, like Newton's laws of motion, for example, aren't just useful for one specific thing.
Right, you said they apply to bridges, cathedrals, artillery.
Exactly. They have an objective reason to be considered useful and true across diverse applications, diverse people, and long periods. They capture something fundamental about reality.
So thinking about our own lives, what stands out to you, listener, as a meme, an idea, a habit, a belief with genuine reach? And perhaps more challengingly, what might be an anti-rational meme, something you accept without question that could be holding you back from exploring new possibilities?
It's a powerful lens to look through. And this capacity for creating knowledge, for solving problems with ideas that have reach, brings us directly to how we confront problems generally and shape the future.
And the first point here, a maxim Deutsch, says we should practically carve in stone.
Is problems are inevitable.
Simple but profound. Problems will always arise.
Always. But the flip side is crucial. Problems are also, in principle, soluble.
Ah, okay. So not inevitable doom, but inevitable challenges that we can overcome.
Yes. And the process of solving them involves what Peter Medawar called the art of the soluble. This applies to all forms of creative thought, including science. It involves making shrewd judgments about which problems are ready to be tackled, which approaches might actually work.
You can't just bang your head against any wall. You need to find the right wall and the right tools.
Something like that, yes. But here's the crucial limitation, which paradoxically is also a blessing in disguise. We cannot prophesy the content or the effects of ideas that have yet to be created.
We can't predict future knowledge.
Nope. And this very unpredictability isn't a barrier to progress. Deutsch argues it's a necessary condition for the unlimited growth of that knowledge. If we could foresee all future solutions, we'd essentially know everything already, and genuine growth would stop. The openness, the unknown, is where the infinity lies.
That has some pretty big implications for how we think about politics and governance, doesn't it?
Huge. Deutsch argues that the traditional central question of politics, who should rule, is fundamentally flawed.
Flawed how? It seems like the obvious question.
Because focusing on finding the right ruler or the best system inherently justifies thwarting opposition to that ruler or system, and it legitimizes revolution and violence against wrong rulers. It locks societies into these zero-sum conflicts over power.
Instead of focusing on systems for peacefully correcting errors and removing bad rulers without violence.
Exactly. The focus should be on error correction, not finding philosopher kings. We even see hints of inherent difficulties in designing perfect systems in seemingly technical areas, like apportionment paradoxes and voting systems.
Right, you mentioned the Alabama paradox, where a state can lose a legislative seat even when the total number of seats increases. That seems totally illogical.
It does, but it's not due to bias or someone rigging the system. It's down to the unavoidable vagaries of rounding errors when trying to divide seats perfectly proportionally based on population fractions. These paradoxes illustrate deeper mathematical constraints, these no-go theorems in social choice theory.
Meaning, there are fundamental limits to how fair or rational any voting system can mathematically be. You just can't achieve all desirable properties simultaneously.
That's the gist of it, yes. These aren't just quirks, they show deep limits. For instance, consider proportional representation versus first past the post or plurality system.
Okay, PR versus, say, the UK or US system.
Proportional systems, while aiming for fairness by matching seats to vote share, often incentivize a proliferation of small parties. This can lead to unstable coalition governments where tiny parties hold disproportionate power.
Right, perpetual negotiation and potential gridlock.
Whereas plurality systems, though often criticized as unfair because a party can win with less than 50% of the vote, tend to be more decisive. They're more sensitive to shifts in voter preference, directly influencing who actually forms the government. There are trade-offs inherent in the system design itself.
Fascinating. So these abstract problems point to practical realities of governance.
And this principle of problems being inevitable but soluble also applies to massive future challenges, like climate change.
How does Deutsch frame that?
Well, he argues that regardless of the precise accuracy of any single climate model, the basic physics is uncontroversial. Continuously increasing greenhouse gas emissions must eventually increase global temperature and eventually become harmful. It's baked into the laws of thermodynamics and radiative transfer.
So from that perspective, he suggests we were actually kind of lucky it didn't become a major crisis much sooner in the industrial era.
That's his perspective, yes. Given the physics, it was bound to happen eventually. The focus then, he argues, shouldn't solely be on, quote, forcing reductions in gas emissions at almost any cost.
What should the focus be then?
While emissions reduction is important, we should also be buzzing much more with plans to reduce the temperature or for how to thrive at a higher temperature. Thinking creatively about solutions.
Things like massive-scale carbon removal technologies, or even more radical ideas like geoengineering, like cloud generation, to reflect sunlight.
Exactly. Applying our problem-solving capacity directly to the effects, or to adaptation, not just battling over the causes. Why? Because, as he puts it, no precautions can avoid problems that we do not yet foresee.
We can't prevent every future problem by just stopping what we're doing now.
No, because new problems will arise from unforeseen consequences or entirely new knowledge. The real imperative, then, is to continuously increase our general ability to solve problems, to put things right if and when they go wrong. It's about building resilience and knowledge-creating capacity itself.
Preparedness through progress, essentially.
You could put it that way. And finally, on this future-oriented note, let's quickly touch on the singularity concept.
The idea that AI or technological innovation will suddenly accelerate beyond human comprehension or control.
Right. Deutsch challenges this. He argues that our capacity to cope with change, driven by the growth of knowledge and the weakening of those anti-rational memes that resist change, tends to increase just as quickly as innovation itself. There isn't likely to be a sharp discontinuity where we're suddenly overwhelmed.
And what about humans versus AIs?
His view stems from universality. If both humans and potential AIs are universal constructors, capable of understanding and creating any knowledge the laws of physics allow, then universality implies that, in every important sense, humans and AIs will never be other than equal. Both are fundamentally knowledge creators.
Interesting. So, wrapping this section up, knowing that problems are not just inevitable, but fundamentally soluble, and that your creative ability, your ability to seek good explanations, is central to finding those solutions.
Yeah.
How might this radically shift your approach, listener, to the challenges you face, big or small?
Does it make them seem less daunting, perhaps? More like puzzles waiting to be solved? And as we reflect on this unique human capacity for knowledge creation, let's talk about something that might seem unrelated at first, but Deutsch connects beautifully: the objective beauty of truth and art.
Okay, beauty. This feels like a shift. How does it connect?
Well, it's often said, particularly in science and maths, that deep truth is often beautiful. Physicists, mathematicians, they call this quality elegance.
Right, you hear about an elegant equation or an elegant proof. It's an aesthetic judgment applied to abstract ideas.
Exactly. Now, elegance isn't the same as truth, of course. As the saying goes, a beautiful hypothesis can still be slain by an ugly fact. Experimental data trumps theoretical beauty.
Reality bites.
But, Deutsch notes, elegance is still a remarkably useful heuristic, a good rule of thumb, especially when seeking fundamental truths. And what's really intriguing is that when beautiful hypotheses are refuted, they are often replaced by theories that are even more beautiful, more elegant.
So there's a trend toward increasing beauty in our best explanations.
There seems to be, yes. This regularity in nature, this tendency, must itself have an explanation. Why should deeper truths tend to be more aesthetically pleasing to us?
And this leads him to think about art.
It does. He sees art, particularly new art, as another form of knowledge creation. Like a new scientific discovery, truly original art is fundamentally unpredictable. It doesn't just rearrange familiar elements in pleasing ways, it adds something irreducibly new to the world, a new way of seeing or feeling.
Okay, so art creates newness, like science. But what about beauty being objective? That's a controversial idea. Isn't beauty just in the eye of the beholder? Subjective taste.
That's the common view, yes. But Deutsch argues, no, there is a universal and objective kind of beauty, analogous to the objective reality of the laws of physics.
How can that be? Our tastes vary so widely.
His argument ties back to human universality. Because we are universal explainers, we are capable of creating knowledge about anything the laws of nature allow. And that includes creating aesthetic knowledge about what constitutes objective beauty. Our appreciation for it stems from this capacity.
He connects it to biology too, right? Flowers and insects.
Yes, it's a fascinating analogy. Flowers evolved bright colors and patterns, objective features to attract specific insects across a species gap. He suggests human artists are, in a way, signaling across the same scale of gap between humans, trying to discover and communicate principles of objective beauty that resonate because they tap into something fundamental, much like those flowers tap into the insect's visual systems. They are striving for objective beauty.
So we connect this back to the bigger picture.
Yeah.
How does our appreciation for art and beauty, if it is tapping into something objective, tie into humanity's unique capacity to understand and transform the universe? Could the beauty we perceive in a sunset, in a symphony, in an elegant theory, actually be a glimpse of objective truth, another facet of reality we're capable of grasping?
It's a profound thought, isn't it? That our sense of beauty might be tuned to reality itself. So we've truly taken a deep dive today into the beginning of infinity. We've explored how knowledge isn't fixed, how it grows boundlessly through this process of seeking good explanations, embracing fallibilism, and maintaining a tradition of criticism.
Yeah, and we've seen how our understanding of the universe itself, from the violent birth of elements and supernovae to the, frankly, bizarre implications of the multiverse, how that really expands our perception of reality and, well, our own place within it. It's much stranger and more dynamic than we usually think.
Absolutely. And we've also reconsidered human evolution not just through genes, but through memes, these powerful abstract replicators, and looked at the fundamentally soluble nature of problems, even huge ones like climate change or designing better political systems. The key is knowledge creation.
Remember, the core idea here is that you, as a human, are a universal constructor. You're capable of transforming inhospitable environments into support systems, not through instinct, but through the deliberate creation of explanatory knowledge.
And maybe, just maybe, the beauty you perceive in the world, whether it's in a mathematical equation, a piece of music, or the natural world, isn't just subjective fluff. It might just be an objective feature of deep truths about reality itself.
So here's the final provocative thought to leave you with.
Yeah.
If problems are truly inevitable and soluble, and if every solution potentially opens up a whole new landscape of questions and possibilities, an infinite horizon, what new, interesting problems will you seek to understand and maybe even solve in your life? And how might that personal quest, however small it seems, contribute to this grand, unbounded growth of knowledge in the universe?